Welcome everyone to part 9 of the ESTeem wireless training class, where for this session we're going to concentrate on one of the product series that we manufacture, which is the ESTeem 195 Narrowband series. This actually incorporates 3 different products, the 195C, the 195M, and the 195H. And what we're going to do is take a look at how these are different. What are these radios? How do they differentiate themselves in the overall system design? Everything that we've covered on the earlier sessions, going all the way back from the beginning where we covered the basics of radio, antenna, cables. We took a look at how we design an RF system. We do a site survey. And now we're past the point to where we were primarily looking at the Horizon series, looking at the modes of operation for that, the bridging, the routing, the mobile, and actually how they process serial traffic across the Horizon series. So now what we're going to do is jump into a whole new product series. It does incorporate 3 different radios, but all of them have very, very similar aspects, and the programming on them is almost identical. So what we're making reference to here is we are actually talking about both a serial and an Ethernet-based radio. It is what we call a licensed band, in the fact that the use of these radios by any user, the city, it does require that that particular application has an FCC FCC license for use of that. Now, what this really gains you is because of the rules that the way that the FCC lays out, these particular applications can generally use much higher output powers than are available on the unlicensed band. So it really gives you a tremendous amount longer range applications, to where 10, 15, 20 miles in these applications is not uncommon. And these are the radios that you also use some of the most difficult terrain. Especially when we're talking about the lower bands, the 150 megahertz and the 217 megahertz. These are what's called VHF frequency, or very high frequency band. And what those do is those are going to penetrate through almost any type of vegetation, will follow the hills to a certain extent. What those do, though, is those are the ones that allow us to get through the most difficult terrain and the longest distance. The downside of those, just as any radio application, there's always a plus and a minus. The downside is that these do not have very, very wide bandwidths. So the bandwidth limitation is going to greatly impact the actual throughput of the system. Now, every one of these radios that we're talking about here, the 150 to 174, 217 to 220, 450 to 470, all of those can support both serial and Ethernet interfaces. The one thing to keep in mind, though, when we're talking about Ethernet, we're talking about a very, very slow speed, primarily just data collection only, to where we can get the data from the remote, but it's not going to be doing any type of networking. You're never going to be able to link 2 different networks together with these devices. You're never going to be able to do video or online programming. It's just strictly data collection is about the only thing that we can process, because the maximum data rate that we're talking about on any one of these radios is about 50 kilobits per second. Now, everything that we talked about in the Horizon series is running into the megabits per second. So it's a factor of 100 difference between the two. So these are significantly slower. Let's go ahead and take a look really quick at the front port on that radio to see what type of interfaces we can take into these. Now, I do like to call this kind of our Swiss Army knife, because the fact that this particular radio can do just about anything. It can support everything from RS-485, which is a serial-based protocol, RS-422, which is another serial-based protocol. We actually have 2 different RS-232 ports, one port that has a full RS-232 complement, in the fact that it has both transmit, receive, and ground, but also has request to send, clear to send, DTS, DSR, everything that you would need on an RS-232 port. The one next to it, the one that's listed as RS-232 for remote power, really only supports 3-wire RS-232, transmit, receive, and ground. The idea was that we could take this radio and put it next to the antenna in much the same way that we could on the Horizon series, because it is actually in the same physical case. The downfall to that is that when we first developed this Ethernet port that you see listed here, that Ethernet port was only produced for programming of the radio. We went this direction because there are very few laptops or any kind of programming computers anymore that really have serial ports on them. So what this did is this allowed us to program the radios through Ethernet, and then you configure it for the type of serial protocols. Well, as the radio evolved through different firmware versions and upgrades to it, the Ethernet actually became a communications port or a data communications port. So that's why it is not PoE, what we're used to, power over Ethernet. It's actually what we call remote power. There's a customized power supply that we provide with these radios that will allow it to go RS-232 and mount on the pole. Most of the applications that these get put into use this auxiliary power input here. And again, that is a 12-volt DC input into the radio. It actually will support everything from 10.5 to 16 volts DC. Around the life of a battery is really what it's designed to do. So looking at this one is a little bit unique, the fact that the status light that we have here is actually what we call a tricolor status light. It actually does everything from off to transmit, receive, and there are two different types of receive LEDs. There's a yellow and a green. The yellow is anything that breaks the carrier detect. The green is once the radio recognizes that the header for that message is actually an ESTeem header, then we change it from yellow to green. So you'll see it as red when we're transmitting, blue when it's linked, yellow when it's recognized that it's got some carrier on that frequency, and it'll go green once we recognize it's an ESTeem response. So that light will actually be flashing quite a bit during the operation. The reset button is just as we discussed on all the other radios. It's the same thing as applying power or disconnecting and plugging the power back in. There's no way to set the radio to factory default or any other parameters through that reset switch. So as you see here, what really comes down to it is depending upon the port that you plug into of the radio, primarily dictates which of the interfaces you're going to be using. Now the programming is done here at this first one. Let me go ahead and pull some of these off so that we don't have so much information. The configuration is actually going to be done through the Ethernet port on the interface. The only one we haven't talked about here is there is also what we call 4 to 20 milliamp sensor. What these are is that essentially of those lines that are in that RJ45 connector, we have several, actually 4 total RS 4 to 20 milliamp inputs that take that interface into it, and then you can read that interface remotely through Modbus TCP. So what it allows us to do is if you're using these radios and they're plugging into a remote tank, and instead of having a PLC out there, if the only thing that's out there is a 4 to 20 milliamp input, we can bring that into the radio. No other controller is required, and that information can be read out of the master radio through Modbus TCP programmed from that radio. So that is quite powerful onto the features available to it. So let's look a little bit more detail into each one of the radios because each one of them is a little bit unique. As you're going to see on this, as when we laid out the different Horizon radios, there are very, very common elements between all of them. The biggest thing is, the biggest change on most of these will come into the frequency of operation and in a lot of cases the RF data rate that they can operate into. For example, the 185M that we see shown here, this is our version that runs from 150 to 174 megahertz. It is narrowband. In other words, it does require it as a site license, but it is compatible with the 2013 narrowband changes. The radio can provide both Ethernet and serial communications. And again, these are primarily serial-based radios that we brought the Ethernet interface into them so that it can bridge to very slow speed or slow data collection type systems, but it does function. It does function quite well. Because of the bandwidth restrictions that we have here, the maximum RF data rate that we can do with this radio is 12.5 kilobits per second. So that would be one of the limiting factors that we have as far as defining this for networking. The radio itself can be set for anywhere between a half of a watt through 4 watts of RF output power. Anything more than 4 watts of output power, we actually have an external amplifier that works in conjunction with this radio that can take it up to 30 watts of output power. So you can get a tremendous amount of distance capable with that. When we're talking about distance or line of sight distances, 10 plus miles, we put that in to be fairly conservative. With this type of a radio, we've easily gone well over 20 miles in very difficult terrain. The vegetation has very little loss characteristics in this 150 megahertz band. The beautiful part is that we've also added in what we call an internal spectrum analyzer. This radio actually has the capability within the software, which is something that we'll look at here in just a few minutes. It has the capability of actually producing what it can hear on the RF channel for this 150 to 174 megahertz band. Now, it doesn't show you what's occurring outside of that band, but if you're curious what's actually happening within that band, this does have a spectrum analyzer for that frequencies. Now, the modes of operation that it goes into, we've got a lot of them listed here. But honestly, it really has the ability to do work as an Ethernet bridge. We can support multiple Ethernet networks. You can telnet into the radio. It can be used as a repeater. A lot of the features that you're going to find really come into the serial network side of this. The radio can be configured for point-to-point, point-to-multipoint. Any one of the remote sites can be configured as a repeater. And as you see down here at the last one, we also support within this radio what we call PLC emulation, to where the radio supports all 3 of the Allen Bradley DF1 protocols, half duplex, full duplex, radio modem, Modbus RTU and ASCII, Opto22, DNP3. Now, the question always comes up, why do we go through the hassle really of looking at emulation within these? Why don't we just produce or send it out transparent? Well, in most cases that would work fine. The difference is that when you look at these PLC protocols, they just have one single destination that they provide. They're really never built for relaying information through a repeater. So what we do within our radio and the emulation side is, if, for example, we're looking at, say, a Modbus packet, what we're actually going to do is we're going to find the destination address within the Modbus and make that our own destination. Well, that gives us the power, because now we have a single remote address. We can then create a lookup table within this radio that says, well, is that radio directly from the master to that site? Or do I need to relay up through 3 radios out to that remote, out to that final destination? So it gives you a tremendous amount of power when putting these kind of systems together to utilize the remote radios within the system as repeaters for other sites. It can greatly create a very sophisticated and complex network at a very low cost. The other thing that is unique to the Model 185M is the fact that it supports what's called MERS band. There are actually 6 different frequency channels available in the 150 to 174 megahertz band that are unlicensed. There are specific rules that you have to use. In other words, you can only use 2 watts of output power, 60 feet in height. You can't use repeaters. Outside of those, though, you can utilize this radio on any one of those 6 channels, and there is no FCC the FCC licensing required. That is very unique for this particular radio. Now, in contrast to this is our Model 195H. As you'll see here, it is an identical unit, has the same interfaces on it. The biggest difference here is it covers from 217 to 220 megahertz in band. It is still considered a VHF frequency band. The biggest difference really comes down into the speed of the radio. This radio can support anything from 4.8 to 50 kilobits per second. Now keep in mind what we're talking about is 50,000 bits per second versus what you're getting on when we're talking about megabits per second on the other, on say the Horizon series. It is a great factor difference between the two. It's not something that's going to necessarily, blow your hair back as far as speed goes. Really, if you look at it, these are about the speed of the old dial-up systems. It's really about the speed that they're covering. It does get the job done. You can gather remote information, but it's not something that you're going to be used for any kind of high-speed networking. Where the ability to go to that speed as compared to, if I look at the previous slide, the maximum we could do here is 12.5 kilobits per second. The reason for that is the 195M, the maximum bandwidth that is allowable within those channels is 12.5 kilohertz is the bandwidth, maximum bandwidth. Well, on the 195H, the bandwidth can go all the way up to 50 kilohertz wide. That is still a licensable channel within the FCC, within the US. So that 50 kilohertz gives us that 50 kilobits per second. I guess you could say, downfall to this channel, the only limitation that we really run into is the maximum power we can do on this radio is 2 watts. This 2 watts still easily gives us this 10 miles. Again, it also has a spectrum analyzer, same modes of operation that we supported, everything from Ethernet, serial protocols, everything we talked about. The only thing this one doesn't have is it does not have any unlicensed channels available to it. It does have wider bandwidths, so therefore we can get through more speed, but it does not support any unlicensed channels. Now, as a contrast to those two is our 195C. Now, our 195C covers the UHF frequency bands from 450 to 470 megahertz. Narrowband compliant, Ethernet and serial, 12.5 kilobits per second, same output power, anywhere between 1/2 to 4 watts, same distance, and same modes of operation that we covered on the other two radios. This is just a contrast. Those are the primary licensed frequencies within the US is the 150 to 174 and the 450 to 470. We also built these radios so that they were actually downward compatible to a previous series, which is the Model 192 series. That series was actually introduced back in the mid-90s. So we worked very hard to make sure that we were able to produce a radio that didn't isolate. We were able to actually talk from these newer series of radios back to our older series of radios, so that even if we're talking about a system that's been out there for 20 years, we're not going to isolate it. We're not going to leave it just hanging as we move forward with technology. So what are the different modes of operation that we can do? Well, there are really two different ways that we can send serial data across the network. We can go completely transparent. In other words, what we receive in at one side can be sent out to either one remote or to all the remotes within the system. The next one is we can also do PLC emulation mode. And as I just described, what the PLC emulation mode is, quite honestly, just very simply the ability for us to recognize the PLC protocol as it comes into the radio, find the destination address, and then we send our message to that one destination address only. Because of that, we have the ability to actually intercept that. And if we need to go through up to 3 repeaters to get to that destination, we can do so within the emulation mode. So it gives us a tremendous amount of power into the type of networks that we can do. There are actually multiple types of Ethernet bridge. Now, this one is a little bit unique in the fact that only bridge mode is supported. There are no router modes within the radio. There are no firewall modes within the radio. It is just strictly Ethernet bridge mode. The one thing that is different, though, is the way that the radio is actually configured. You actually have to tell the radio specifically which IP addresses you want the radio to handle. So in some ways, you configure it much like you would a router, but think of it this way. Normally a router, you say, okay, let this block of addresses go through. These radios, you have to tell it specifically which addresses you want it to pass. So it does not do any kind of routing in the fact that it will keep other radios out, but it functions in much the same way because the radio will only send across from the RF side specific designated remote IP addresses. So you are effectively building a router from the ground up. Instead of restricting which addresses it goes to, you have to tell this radio specifically which addresses it uses. So because of that, you can support either a single remote or even multiple remotes, and repeaters are supported. When we're talking about remote I/O, what we're talking about is those 4 20 milliamp inputs. If you've got a simple application to where all you're doing is trying to read this information back, any one of these radios, the C, H, or the M, can bring that information in without having to have a PLC attached to it. So how does this all work? Well, we've looked in previous sessions, we've utilized one of the utilities, which is called the Discover utility. The Discover utility is designed to set the IP address on the radio to match up to the connected computer. Well, we've embedded within that Discover utility 3 different versions of this 195 narrowband utility. It is all Java based, just like the system. It's actually found within the Discover utility. So what we'll do is when we give a demonstration of it here in just a few minutes, you'll see here that we're utilizing the same tool. It's just there is a utility buried within the Discovery, which we just really have never used before. The one part that is very unique and it is very helpful, especially on modern systems, is the fact that even if you're using RS-232, all the programming is done through the Ethernet interface. So your computer that you're using does not have to have an active serial port on it to actually program these radios. You can program it through the Ethernet port and connect it to, say, a controller that has a serial port. It's necessary for you to have a serial port on the computer itself. What you're actually doing as part of this configuration is telling the radio what is going to be the data interface and what is going to be the mode of operation. One thing is that the radio can only support one single data interface. So you're going to select the data interface. So if it's RS-232, RS-422, RS-485, or Ethernet, this radio series can only support one. So unlike what we can get in the Horizons and even in the 210 series, we cannot do both serial and Ethernet data communications at the same time. It can only support one of those, right? So what are the different types? When we're talking about a serial data transfer, we actually have multiple different data types. We can support RS-232, either full RS-232, where we can support hardware flow control with request to send, clear to send, DTS, DTPSR, RS-422, which is another serial interface primarily done for long range or long distance serial applications. Anything over, say, 100 feet of cable between the two would require that you have an RS-422. As kind of a subset of RS-422 is what's called RS-485. RS-485 is actually a multi-point or multi-drop serial protocol. It's really one of the only multiple type of interfaces out there that'll allow that. So we can support any one of those 3. The emulation modes that we support from Rockwell, we can do the DF1. One thing it's very unique. Only ESTeem products can actually support DF1 full duplex protocol. It is getting to be one of their legacy protocols, but it is unique in the fact that because we actually gather the destination address out of the message block and send it to only one remote site, we actually can support this full duplex protocol. We're the only manufacturers in the world that can do that. In addition to that, we can support DF1 half duplex, which is kind of the classic serial one, or even their upgraded DF1 radio modem protocol. As a matter of fact, we've even gone in and made a firmware version within these radio that is optimized specifically for DF1 radio modem protocol. It allows it to transfer tremendously faster across the network and support remotes communicating with each other, which is very, very unique. We support Modbus RTU and ASCII, Opto22, and DNP v3, which is primarily a power utility protocol. All those serial protocols, we actually have an emulation driver written for it. If none of those match up to the type of serial network you're putting it into, we also still support transparent mode, to where what data comes in goes out the other side. And to be honest with you, everything outside of DF1 full duplex could function within transparent mode. But the emulation driver just allow us to add in repeaters. Now, when we're talking about the Ethernet side, what we're making reference to here is bridging. Again, the Ethernet device and the IP address must be listed. In other words, you have to tell this radio specifically which IP addresses you want them to handle. So we need to list in there not only the remote radio that we're talking to, but all the connected devices. So it is a little bit more programming when doing the Ethernet data, but as I mentioned to you just before, this is essentially creating a router without a router mode. You're actually telling that radio to only service these particular remotes. But unlike a router, this one is actually bidirectional across it. It's actually all done through what we call the routing and the append tables. Now, the routing and the append tables are utilized in the serial side for repeaters. Same thing, we're going to use those exact same charts. We're going to use them a little bit different, but what we're going to do is we're actually going to group IP address together to be serviced by a single remote radio. The reason that we say it's got very tight IP address control essentially is that we have easy router functionality in the fact that you have to tell that radio specifically what IP addresses are going to allow to go across it before we actually will allow that data to go across. One nice feature that we've added, and where a lot of these radios have been utilized, is to existing Model 192 systems. As kind of a testament to the power of those radios, as I mentioned to you, they were released in 1996. There are actually many different systems out there still utilizing these Model 192 radios. Because of that, we did not want to pull the rug out from those customers, and we try to service those our existing customers as best we can. So the Model 195C and the 195M are actually compatible with the Model 192C and the Model 192M radios from our legacy version. There is one caveat to that, is the fact that we do have to support this into what we call legacy firmware mode. And I'll show you explicitly how that is done. But that is one of the key things that we then do. The what we'll call non-native mode, in other words, the radios themselves, when they communicate Model 195 to Model 195, they can actually go up to 12.5 kilobits per second. That's because they just inherently communicate faster with each other. When we're going to make them compatible with the Model 192, what can actually happen is that the slower speed radios, we actually have to roll them back to 9600 baud, which is the narrowband equivalent in the Model 192. So it does run a little bit slower in those modes, although you'd probably never recognize it. The way that this actually functioned is we are actually making this radio go out, talk to a specific Model 192, and says, okay, I'm going to then find your I'm going to find actually what your bandwidth is, and I'm going to match my bandwidth to yours. The Model 192s were not very tight as far as how the deviation level was actually set with them. In other words, how far off the main carrier did the radio actually modulate. The Model 195 being a newer radio, that is very, very tight, is very, very specific. Because of that, we need to match up, or essentially train the Model 195 to talk to a specific Model 192, because each one of the Model 192s can be a little bit programmed a little bit different. Because of that, what we're really doing is that this can only be utilized as a compatibility at a remote node. In other words, you can't have a Model 195 communicate to more than one Model 192. So in those cases, what we recommend doing for if you needed to replace the 195 to put it into a Model 192 location and it's at the master or the repeater site, it's not going to work there, being the Model 195. So what you would have to do is you would then go to any one of the remote sites. It doesn't matter which one. Take that radio, program it to be the master or repeater, and then put this model 195 at the remote. The caveat to it is the fact that the model 195 can only talk to one model 192 within the network. That's really the way that it functions. So what are some of the availabilities? What do we have available to us? Well, there are several different modes of troubleshooting this radio. How do we find out if they're talking? Well, the radio itself actually has part of the utility is what we call the diagnostics. Now, what the diagnostic utility will actually do is it actually does essentially creates a dummy packet and sends that across to the remote site, and it will continue to do this. So it will show you current transmissions, how many retries, whether the link is lost or not, and it will actually give you the received signal strength from both sides of the system. Because at the same time is it not only sending information, but it's also reading the remote signal strength over the Modbus TCP. Now you also have the ability to go in there and utilize the console. Well, within the console, you have direct control over the radio to where you can do some high-level troubleshooting into this that you actually required separate piece of troubleshooting hardware, which was the packet dump. This actually does the same function as a protocol analyzer. So this will actually show you how the radio is transferring serial information within the actual device itself. So you can see the serial packets coming out of the radio and going back into the radio without having to disconnect it. And that's all done because you're doing this through the Ethernet interface on the radio. We also have the ability to do what we call packet monitoring. This will actually do a breakdown on the screen. This is something, of course, you can save within the system too, but it'll show you exactly what the radio is communicating with from one side to the next, so you can walk it through there and see exactly how the packets are moving within the RF system. In addition to the diagnostic and the console information, we have the ability to utilize a spectrum analyzer. So if there's concern that there is RF traffic that is interfering with the system, the spectrum analyzer will give you a visual representation of it. The next thing is that the firmware can actually be updated, and it's actually stored within the utility version itself. So if we look at the three different modes of operation that the radio can do, what we call serial protocol, legacy protocol, and Ethernet protocol, the firmware version is actually embedded within the utility also. So there is no additional files that need to be downloaded for those systems to actually work. To give you an idea of how the spectrum analyzer does, it is actually just a tab within this configuration tool, which we're going to take a look at in real time here in a second. The one thing that does happen though is when you turn the spectrum analyzer on, you're effectively turning off the radio functionality. The radio will no longer receive, it's never going to, it's just effectively in listen mode only. The one thing it will do as soon as you turn the spectrum analyzer off or you move to a different tab, it'll actually reset the radio when you're leaving that analyzer mode. So what are some of the programming capabilities that we can do? Well, a lot of the same software commands that were available in the Model 192 are also supported in the console mode. Simple things like changing the address, turning the radio on for measuring the forward reflected power, connecting, disconnecting. There is a complete list of all of these essentially console commands available through the user's manual. If you, the utility is fantastic for doing a lot of the programming of the system itself, but if you want to get in and actually get to the higher levels of it and do some advanced programming, we would probably have you go into the console mode and utilize some of the features there. The next thing is that the radio itself actually has an IP address, a TCP IP address. Because the radio is primarily a serial-based radio, the way it gets its address is actually the last octet of an IP address. So for example, if the radio is programmed for 172, 168.209, the unit address or the address of that radio is going to be that last octet here, which is 209. That becomes very important because when you're looking at the programming of the radio, you will match the serial configuration to the device it's connected to. So if you have a remote PLC and it's address 10, the radio that's connected to that also needs to be address 10. So the last octet, no matter what the IP address, has to end in .10. That's really the only thing that's absolutely important here. The next thing is as far as setting the RF power level, everything that you do here, there is an advanced configuration screen to where you can get in and actually change all of the different parameters. You can read the configuration, change the power level, and then write the configuration. Just like we saw when we were going through the Horizon series, it is always a multi-step process. You change the parameters within the radio, and then you have to save those parameters. It's exactly the same that we have here for this Model 195 series. So what are some of just a couple programming tips? The biggest thing that we need to be able to do is we have the ability to actually do a remote program. There's two methods of doing that. The reason that we put it this way is it supports the Model 192 mode, to where you're on a console line. You type in the command PROG space and then the address of the site you want to talk to. And then it will respond back and essentially give you a command prompt from that remote side. That's something that if you're utilizing a Model 192 or you're familiar with it, it will reply to that. You also have the ability of going and actually telling this radio, am I going to be utilizing the local IP address or the remote IP address? So within the utility, you can actually do a remote program within the system. And there really are two methods of actually saving the configuration. So you can save and load it either under the file page that we have listed here, or if you right mouse click anywhere in the advanced configuration screen, you have the ability to do so also. So let's go ahead really quick and take a look at what this does. So what I'm going to do is I'm going to open up on the screen here the Discovery utility. Now, as you notice, this is the same Discovery utility that we used for all of our radios, whether they be the Horizon series, the Model 195, or even the 210 series. All use this same Discovery. So if we press the Discover, the only difference now is that you're going to see this radio is going to come back. It's going to tell us it's a 195C, which is a UHF radio, the firmware version. It's just going to tell us what mode this one in. This one is actually an RS-232 on port number 3, which is the third one over. The SSID, because there really is no SSID within the radio, so what's actually put there is the frequency of operation and the power level. And then, of course, we've got the IP address and the net mask. So one thing that you will see now is that the the address of that radio is actually going to be 135, and you'll see it up on the screen. Now, what is a little bit unique here is just like in the Horizons where you do a right mouse click and you hit configure the radio, if I do a right mouse click on the screen, you'll see here that I actually have 3 different versions available to me now. We can change the IP address, we can change the configuration password, what it's going to ask me to by default to get into it. But the 3 different versions, the way that it's broken down is this 195 narrowband serial protocol. This is the one that we've optimized it for DF1 radio modem protocol. Anything other than DF1 radio modem protocol, the legacy ones, the half duplex, the full duplex, the Opto22, Modbus, all of those will be in the legacy version. The 195 legacy and 192 version is listed here. If the radios are going to be used for Ethernet transactions or Ethernet bridging, then you'll utilize the Ethernet firmware. To be honest with you, there is no hardware change that goes on within these. Every one of these essentially is optimized for the type of protocol that is going to be coming into it. Let's go ahead and take a look at the first one. We'll just go ahead and start here with the 195 narrowband serial. So I'm going to select this. Now what's going to happen is it's actually going to pop it up because I've got a dual monitor here. It's actually popped on my other screen. So I'm going to put it over here on this page so we can see it. So what it did is it opened us up, tells us our local IP address. 172.16.8.135, and you'll see what it does is it actually pulls that address. So the address of the radio is that last octet. You set the frequency, you can set the destination, and we can set within the serial protocol what type is it going to be. Is it going to be transparent, or is it going to be a PLC emulation? And again, like I said, this is primarily optimized for DF1, Allen Bradley DF1, and it's going to be best optimized for radio modem protocol. So there's two ways that you can program it. You're either going to program it as the master or the remote. Very simple. And you're going to match up the address of the connected device to the PLC that it's hooked into. There is more that goes into this and how these are assigned and how the routing and appending the pen portions work. What we do is we've actually got separate technical bulletins, we've got separate engineering reports for these, and we are actually going to have a separate video specifically which one of these to select and how to configure it for the different applications. It's kind of outside of what we want to teach here, because otherwise this class will go a little too long. We're going to use this as more of an introduction. But to give you an idea of what I'm talking about as far as an example, this is an active system. So if I wanted to program this radio to say 455.5 megahertz, I simply change a parameter here, go down to the bottom here, hit Write Configuration, and what it's going to do is it's going to send it over to the radio. The radio is going to program, and then it'll come back and reboot. And then it will display the changes of what it's read right here on the page. So now the radio is set for 455.5, and as you see here, the radio reboot and cycle process is tremendously faster in these radios than we ran into in the Horizons. The Horizons are about 45 seconds for it to reboot. These reboot in about 10 seconds. And it really comes down to it has a much, I guess we'll call it a lower grade processor, and the fact that it really all it's doing is utilizing the communication just for this radio. The next tab over here is the route and the append, and there are really what it comes down to is you have the ability to set within the radio what are going to be the routes. So we have two different ways of doing this. The first one is what we call the wizard view, which really what it's going to do is this one is designed primarily for the Ethernet bridge. So we'll cover that here in a second. If we do the list view, what we can do is we hit edit, and what it's going to do is it's going to ask us what are going to be the routes, what are going to be the repeater addresses we're going to use, and then we scroll down a little bit further. We're then going to find what are going to be the addresses that utilize those routes. Again, that's kind of outside of the scope of what we want to teach here today. Just the fact that if you are going to be using repeaters, and again, we need to identify each one of the remotes of who it's talking to. We put it in a designation of where it communicates or what is the route it goes into. If we go to the advanced configuration, we have the ability to go in here and read the configuration. And what this will do is this will then list out all of the command parameters within the radio. So for example, there's the frequency. It'll list out all the different command parameters available that can be changed within the radio, specifically within each of those individual parameters. Now the difference here is that this one lists all of them. If you want to look at, say for example, those that are related to just the radio side of it, then we hit read. And so what it'll do is it'll bring up the channel spacing, the deviation level, the frequency, and the power levels. Those are the only ones that have anything to do with the radio side of it. Same thing if we break it down by the PLC. It's going to do just the PLC commands. Or if we want to look at the interface side of it, hit read commands. These are specifically for the interface side. What is going to be the serial settings on the parameters of the radio. So what's going to be different here is that if you look at the configuration that we're doing here, as far as data rate, parity, baud, everything like this, those are the same parameters. They're just laid out a little bit different on the screen. So it just gives you the ability to actually go in there and adjust these parameters one at a time. You have the ability to reset the radio, set it to factory defaults, Modbus monitoring. That's a fantastic way of actually testing the communication, because what you can do is if you go up here to the top, change this to remote, and then put in, say, a remote IP address. So 16.8. Let's say we had out there at a remote, say 200. What it would then do is you can hit Modbus monitoring, and it'll bring up all of the command parameters from that remote radio. The only downfall is that I only have one radio plugged in here, so I don't want to do that because we don't want to throw an error on our screen here. So I'm just going to keep it back at the local IP address, but this allows you to basically talk and look at what's available at that remote site. If we look into the diagnostics, the diagnostic tab allows us now to essentially send out command parameters very similar to the way that a TCP IP ping does. It'll send it out to the remote, send it back to the user where it came from, and it'll tell you how many times it's sent that information, what size of the packet it's sending across, and did it take any retries to do so. Again, 10% retries, even on any kind of the best system, 10% is about the best it's going to get. So you can always expect at least a 10% retries. The only difference here is you just put in, quite literally, the address of the site you want to test. So if I hit add units to test, what it's going to do, it's going to pop up a window here that showed up over on my other side. So then you put in, say, I'm going to then go to, if I had a repeater address that was 10, talking out to a destination that's at 200, then what we can then do is we hit finished, and what it'll do is it'll put, this will be a test address. So if I hit starting test, what it will do is it'll try to communicate to that remote, but as you can see here, the only thing it's doing is retrying. So our retry count is going to go up. So if I hit stop the test, it'll actually reset the radio itself. But as you noticed here, we had 21 retries. We never got any data through because I've got no remote to talk to. The firmware version. As I mentioned to you before, there are 3 different types of firmware available. This one here is optimized for DF1 radio modem protocol. The easy way to tell if the firmware is up to date, if you hit the button that says update firmware, if that firmware version is what's programmed into the radio, then it'll say firmware already up to date. And I'll show you here as we change to the next one, what'll show up if it's not optimized for it. The next tab is actually the console tab. The console tab is the direct interface into the radio. As I mentioned to you, we have imported many of the same command parameters that we did from the Model 192, or some of the features that allow you to do more direct information. So for example, if I type in frequency, this will tell me I have 455.5. If I change this to, I can type in frequency, and I change this to 450 megahertz. It changes the frequency. Same thing for RF power. So the RF power level is set at 4 watts. If I then change the RF power level, RFP, if I change it to a value of 4, it's actually going to change it to 2 watts. Now again, these command parameters are only going to take effect if I actually then type in the command save. So though I've made these parameter changes, if I type in the command reset, they essentially go away. The last thing I want to show you is what the spectrum analyzer looks like. If I click over here on Analyzer tab, what it will do is you'll notice here is you have the ability to set the frequency. Now, by default, this will always, no matter what frequency you have set the radio to, it'll always center the frequency at 460. So if your operating frequency is 455, you may need to move the center frequency to 455 megahertz. Or you can actually even type it in. 457.5, let's say, is the prime frequency. That's going to be the center line of the spectrum analyzer. So you can do everything from adjust the span. It's going to set the reference level. So if you're in a very noisy environment, you can adjust the reference level down. If you're going to be utilizing an external attenuator, because it is in a fairly noisy environment, you can put the value of the attenuation in here. And what it will do is it will just change the scaling. So for example, if you see here where it says the top line by default is a -80, if I actually had a 20 dB attenuator in there, you'll see here it changes the reference level to a -60. So it's really more for display purposes than anything else. So I'm going to set that back to 0. You can put up a display line, peak hold, a marker, and a delta on those. And so we'll go ahead and run one real quick. I'm going to go and enable the sweep here. As you can see on the screen here, now we have an active spectrum analyzer. What we're looking at here is the center line, of course, is going to be our center reference at 457.5. So if you're going to be looking to use the spectrum analyzer for your application, the best way to do this is to put your frequency of operation is the center frequency, and then you have the ability to actually look at different span levels. So the wider the span, the more you're going to get. So I have here 1 megahertz wide. There are 10 divisions, so each one of these divisions represents 100 kilohertz in between them. The display line is just a way that we can put a line on here, put a reference to it. So if you're trying to measure how much signal is coming into the remote side, it'll allow you to do that here. You also have the ability to put a marker on there and move this marker around within the system. So if you're seeing a peak come up, let me do this. Let me go ahead and go back to a frequency that I know there's activity at 460 megahertz. All right. As you can see here, we have a small peak down there at the center. So if we wanted to put a marker on that, what we could do is we could put that on that point, and this will tell us the marker is actually running at the frequency 460 and how much signal there is. So if it was much higher than that, as you can see here, the reference point is changing. The only difference here is if you have put up a secondary marker, you could put a secondary marker down here, and this will actually tell you the signal strength difference between those two markers. For details on exactly how to use the spectrum analyzer, again, we've written a technical bulletin specifically for this, but we've also got a pretty good explanation of it in the user's manual and how that works. The one thing to keep in mind is when this is running as a spectrum analyzer, the radio itself is no longer functioning. So if you hit enable sweep or turn it off, or come out of this tab at all, what's actually going to happen is the radio will actually reboot because it needs to go back to it. So the last thing I want to show you really quick is we've looked at the serial version, which again is for the DF1 protocol. If we go back to the radio, we'll clear the list, hit discover. If we do a right mouse click on it now and go into Ethernet, what's going to happen is we're going to have two messages that pop up. The first one is we're going to get a message block here that says, just warning that the installed radio firmware that's in the radio itself is not optimized for the Ethernet mode of operation. Would you like to update the firmware? Now, if you hit cancel, it's still going to run on the old firmware version. But if you click OK, what it will do is it will then open up the utility and take you to the firmware update tab. As you can see here, this says Ethernet radio support, so we know that's the version we want to do. If we're going to run it for Ethernet to update the firmware, you just simply hit update the firmware. What it'll actually do is it will actually send it across and update the firmware across here. Now, unfortunately, what's going to happen is this usually happens incredibly fast, but I'm also utilizing the same switch for the recording of this. So it is going to take a little bit longer going through there. But what it will actually do is it'll send it across, send up the update, and then tell you it's finished, and then reboot the radio. The only thing that's any different here is I'm going to go ahead and abort the update. And I'm going to close this down because I want to show you one last little piece here, which is where we get in there and hook this thing up to a Model 192 series. So if I do a right mouse click, go into Legacy 192 mode. Okay. Again, I got the warning message here that popped up on the screen. It's not for 192. For our purposes, though, we're not going to put it at that firmware version. I'm just going to show you what is different here. Because depending upon the modes that you put the radio into, it's going to then show you what is necessary for each one. What I mean by that is if you put it into the 192 compatibility mode, now we have a 192 compatibility tab. So really it's just as simple as turning on the compatibility. You set it to on, you set the radio that is going to be programmed for that. You go in there, put in a remote address, say the site you want to train this radio for is going to be address 35, and you hit train to remote. And at that point then the radio will go out, find address 35, talk to it, find out its deviation level, match its deviation level to it, and automatically program to talk to it. It's just that simple to make the radio talk to the legacy Model 192s. So the 192 series is a fantastic kind of Swiss Army knife in that it can handle just about any type of interface. The only downfall to it being the fact that it is on a very limited bandwidth of operation that it can go. So the speeds that it puts across there, the maximum we can do in this series is 50 kilohertz or 50 kilobits per second. So although it does solve many applications and has great, it is somewhat limited as far as the speed that it can go across there. So the next class that we're going to be going into is our other radio that is designed for operation within these licensed frequency bands, and that's going to be our Model 210 series. It works much in the same way that the Horizon does on the programming and the configuration of it. The part is that we're going to cover how it actually functions over these small channels. So I look forward to talking to you then, and thank you much for your time.